So this is my third total solar eclipse. The first one was my father. I was only like barely 16 years old, and he drove me to Cap Canada, to photograph the total solar eclipse. And we went up there, and as I set up my telescope to photograph it, it turned out that I brought my 10-inch f6.5 Newtonian telescope that I built too. The sun was 99, no, the moon was occulting the sun by 99% of the sun, and then the clouds went over. And I got a picture of this little sliver, and that was it. I was a long time ago.
72.
Yeah. Then I have photographed other eclipses in Aruba and Saskatchewan, Canada. And then after I graduated high school, I went to a friend of mine, and he's now a meteorologist, and we actually drove and ended up in Saskatchewan, Canada, to photograph a total solar eclipse, and in February, and that wasn't fun. But I had this van all set up for survival, and I photographed that one. So all my eclipse photographs are not digital, so I'm not including any of my pictures here. But I'm going to go through. So basically, a little bit about a total solar eclipse is that here's your sun, here's the moon, here's the earth, okay? And this is a section on the earth that you're going to see totality. Where else in the solar system can you see a total solar eclipse? Nowhere. Only on Earth. So we are so privileged that we're able to see this event only here on Earth. So this eclipse is going to go from Canada straight down. It's going to end up, this is around Rochester area, straight down into Texas area. So I'm going mobile because I don't want to take any chances in the weather. Hopefully it'll be in Rochester. It's only a 7.5 hour drive, and I'm not going to be able to drive all the way to Texas. So I'm going to go mobile, and hotels are going for crazy amount of money, and they may not even have a hotel. I'm bringing my tent in case I have to go camping if I can't find a hotel. But I'm basically, when I'm going to find hotels outside the area and then go there. That's my plan of attack is. So this is quick facts. The total solar eclipse is on April 8th, 2024. The next total eclipse can be seen in the United States in August 23rd, 2044. Where are we going to be at 2044? I don't know. We normally can't see the corona on the sun because the sun itself is so bright. When the moon occults the sun, it blocks it out so you can see the solar corona. We're going to talk about that in detail later on. And so that's how, but during a total eclipse, the corona becomes visible and you'll be able to see it. It has unique opportunities. When the moon completely blocks the visible surface of the sun, you get to see, you get to remove your solar filters out and see totality. And that's remarkable. I can tell you, when I went to Saskatchewan during totality, I heard all the birds chirping just as totality happened. It was quite obvious when totality, all the animals thought it was nighttime and was chirping. So those of you that are going to go look at the eclipse, that may be a real possibility wherever you end up at. During a total solar eclipse, the corona briefly comes into view as the moon blocks the surface of the sun. Okay, and the corona is wispy white streamers of plasma or charged gases that radiate outward. I believe the corona is almost like in three-dimensional, but we're not seeing it that way because of where we have positioned the Earth and the sun. Okay, so that solar corona is a very active region that goes all around the surface of the exterior part of the sun. Okay, so when you want to photograph the partial phases of the solar, you need a solar filter. Okay, so basically these are the solar filters that I have, and I have two different types, and I'll tell you why. This is a Mylar filter, which is what I highly recommend. Okay, this will not deter your images at all. It's a thin piece of plastic that is has a density to it that allows you to safely see the sun. Okay, so this won't change your image.
That's like black plastic, right?
Yeah,
Yeah.
it's it also is solar filters is a space age blanket. I remember correctly. You can make that into a solar filter, the space age blankets. I've done it in the past before. I haven't done it in a long time, so I'm not really sure. But I know people were doing that. That's making that. This filter here, I've had forever, and this is glass. Okay, which I don't recommend, but I bought this a long time ago, and this is a high quality glass, and I've used it. It works quite well. But in today's market share, don't buy a glass filter. Get the Mylar one. Okay, so that's.
Who manufactured that one, Tony?
I have no idea. I bought this, I don't know, a long time ago.
Bader Planetarium has a material.
Yeah, I'm going to talk about
The
where
thing
you
is,
get the
you
filters.
probably need to get it now.
I'll talk about it a little bit later on about where you can get some of those filters. So there are many ways to photograph an eclipse. I mean, some of you may want to use a cell phone. And if you're going to use a cell phone, all cell phones are not created the same. I know, like my cell phone, I can get into the photographic sector. I can change the ASA. I can change different parameters on it. So you have to look into it.
Just a point. ASA, most people call it ISO.
All right, ISO, ASA, it's the same. Yes, all right. So it's all the same, ISO or ASA. You can change it. I say about 300. You can go up to like 500. You can go down to 200. It won't make a huge difference, but you don't need to put it up like above 500 in ASA. And then focus. Sometimes if you have your cell phone, take a picture of it, it may have a hard time focusing on the eclipse. So you'd have to, what I suggest is get a Mylar and put it in front of your camera and at the sun and see if it takes a good picture of it. You have to experiment. And I don't know, because I don't know what kind of a cell phone you have, because you want to make sure it's going to be in focus. My gut feel is it probably will. Now there is a lens that you can buy. I don't know if you can see this. I'll put it here. This is a lens you can buy. You snap it onto your cell phone. In fact, I'll show you mine. You can buy this, and I'm going to tell you where you can get all these goodies later on. You can snap it on here, and now I'm going to be taking. Hold on, camera. Now this is the one I happen to pick is a wide angle lens, and but you can you see? Yeah. So you can buy different types of these lenses that go onto your cell phone, and they're cheap. Okay, and I'm going to tell you where you can get it like dirt cheap at the end of the talk. You have to go online and look. They go from, like, this one's the wide angle lens up to a telephoto lens. So they have different what you have. So the main thing is that you have to play with it. So if you're going to go ahead and photograph with your cell phone, this totality, this is primarily what it's going to look like. Does anybody plan on using your cell phone to take a picture of the eclipse? I got you a toy. This you attach to your telescope. I'm going to give it to you, and your camera gets your cell phone gets hooked up here. This you attach to your telescope, and you move it in place, and that's it. You said you want to use yourself?
Depending on, if not.
So it works. You'll have to play with it with your cell phone. All right. So how can I get over here now? Must have pressed the wrong mode. Now my remote's working. Where the hell am I? Where did I end up at? Okay. Okay, so that's when you're using your cell phone. Cell phones are doing a great job today. So you may get yourself some really good photographs with your cell phone. So again, that's what it's going to look like if you're going to be your cell phone to take a picture of totality. So now you're going to use your camera. I'm going to start talking about my telescope right now. This is in two sections. I'm only going to talk about the telescope, and I'll talk about the mounting at the end with this mounting. So this is your telescope. You can hook your camera to your telescope. Now, what I suggest is that depending upon the altitude of the sun, if you have your camera straight through it, it's going to be really difficult depending upon to look through it. Put a right angle diagonal on it, put your camera on top. Okay, that's one of the suggestions I can make. The other suggestion I can make is that if you have your camera, your 35mm camera, you can buy a right angle attachment that hooks up the eyepiece, which I have, and you can look down on it that way. But if you have a diagonal and you don't want to spend the extra money, put the diagonal there. The diagonal should be fine, and it's just more convenient for you to use it. Okay, and then when you're looking at the partial phases, you can focus it. The beauty of today versus in the past is that the past when you had film, if you didn't have it in focus, you're out of luck. Today you have a camera, a digital camera, and you can see in the viewfinder screen exactly what you're doing. So that's the beauty of digital technology. So you can see exactly what you're doing. You can see what the image looks like, and you can see if it's in focus. So then you focus it, and then you know, obviously, when the first thing is when you have totality, which I'll talk about here too, is that as soon as you see its totality, stand there and just look at it. Don't photograph it. It's going to be a 4-minute so eclipse. Spend a minute or so looking at it, and then once you're there, then you just remove the filter. That's it. And then you put it back on after it is. I'm going to talk about that a little more in detail later. Okay, so I don't know why this is working now. Okay, so these are different millimeter lenses that if you're going for photographic from, it's a 200mm, 400. This is what the images would look like when you're different focal ratio, you know, of lenses or telescopes that you may have, what it would look like, just to give you an idea on what you're doing. So, and I'm going to talk about that a little more in detail. You can take a picture of this because I'm not going to explain it. These are different exposures that you may want for Bailey's beads, chromosphere, blah, 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 corona. So the ISO ratings here. But when you go ahead and you want to photograph it, the first thing is to take your telescope out the solar filter and do your imaging before the eclipse and make sure you get the proper exposure on the sun. So you're going to have to play with it on everything ahead of time. Don't chance it and wait until the eclipse, because once the eclipse comes down, you're not prepared properly, you're not going to have good results. When using a telescope photographic, make sure your mount is good enough to take a 1 minute exposure. First thing is, this is the next generation mounting. It's called a harmonic drive mount. This does not need counterweights. It handles up to 45 pounds, no counterweights. If I want to go up 60, then I can put a counterweight on it. I don't plan on it. So this is the next generation. This is what I feel all the telescope mounting is going to be in the future. There'll be no counterweights. Not needed. This is rock solid. This whole thing is rock solid. So now, as far as pointing it, you should have a compass and point your German equatorial mount to the north as close as you can, and that's going to be good enough. Once you know it's north and you have a compass, that should be close enough. There's other things that you can do to, which I'm not going to get into, to make it more accurate for pointing it to the north. You know, due north. Because if you're going to take exposure up to 1 minute, it's not that super critical, but you want to get as good as you can. Now, to find the sun, you want to get this finder here. This is a solar finder. It's a very simple device. It's got like a small pinhole here, and you got so it the image will present. You'll see the sun on here, and once you have the sun in the center of this, then you know it's going to be the center of your telescope. You gotta do this ahead of time because you got to make sure everything's in place properly. This finder scope has got to be in place properly. You're gonna have to play with it till you get it right in order to do it properly. So you have to prepare for the eclipse. So you're gonna be taking exposures, you know, from actually, less than 20 seconds, all the way up to maybe a minute or so. The longer your exposure is, you're going to overexpose the sun, and the black part of the sun will turn whitish because you did a long exposure. But your corona will get hugely big, and then as you decrease the exposure, the corona will get smaller and smaller and smaller. Okay, so oh, this is out of place, but this is so this is about telling you taking a series of exposures when you're practicing it. So when you're photographing the total solar eclipse, these are the two things that are important during a solar eclipse. One is the solar flares, to see the solar flares. To get this, you need a short exposure. When you do a short exposure, you're going to not see much of the corona, but if you're lucky enough, and there's no guarantee, you'll see solar flares coming out of the sun, which are really cool to see. My gut feels you'll probably see solar flares, just like the same thing looking through a hydrogen alpha telescope. It will look just like that for the most part. So if you go ahead, if you take longer exposures, then you're not going to see the solar flares. You're going to see more of the corona. So short exposures, let's say a quarter of a second or less, you're going to see these solar flares here. Now, this exposure, tiny bit of the sun was just exposed here when this picture was taken. You still can see the corona, but it's very small, but you're seeing all these nice solar flares. So you're going to take a very short exposure, and that's what you're going to see. Okay.
So Tony, if you do a longer exposure,
I'm getting up to that.
You're seeing the corona. How do you attenuate or lessen the flares?
Well, you won't. What happens is, as your exposure gets longer, your solar flares will decrease. You won't see them because you're overexposing them, and the corona is there. You'll see what I'm talking about next. So this is a longer exposure, like greater than 45 seconds. Now you're going to see the corona. Okay, you're not going to really see any flares here, but you could see some, like there's some hesitation of something here. But look, if you look careful enough, you can't see it. The flare really can go way out. You don't really see it here. But as you increase the exposure, you're going to see more of these arcs that's going to go downward. Now, this is no guarantee what the eclipse is going to, the corona is going to look like. It's going to be always unique. Every eclipse has a unique corona.
Is that the 2017?
What? I don't know.
2017.
None of these pictures, I don't have any actual dates on when they're exactly taken. I just did it for my talk purposes. So what you see, phases in totality. So this guy, somebody did this, which is really cool. So this shows you the whole thing about the total eclipse. So this is where the sun is uneclipsed, and then here it's getting eclipsed. So you're going to take pictures along the way, as many as you want. Now you can space them every 5 minutes, every 10 minutes, every half hour, whatever you want to do. It's up to you. All right. I don't go crazy with all these partials, but I usually do in groups and I take it. Then this is known as the diamond ring. This is the diamond ring. Why? It looks like a diamond ring. And so that's the diamond ring. And then it goes into the total solar eclipse. and then it starts to leave, and then you're back in the partial phases. So this one here, here's a diamond ring. So this is a fast exposure. You see a solar flare here, and that's exposing a little bit of the sun. Same thing over here, the diamond ring over here. This is a picture of the total eclipse, but it's made with stacking. It's made with multiple images. A friend of mine, when I went to Saskatchewan, really brilliant guy, and he's really big in computers. He wrote software that did this back in the 70s. I have it on my desk, this picture. So this is taken with many exposures all at the same time, stacked together. So you get to see more and more detail of the corona. So it's never going to look like that. It's only because he stacked a whole bunch of pictures. And here's another one. Okay. Now you can see the poles. The reason why I put this one here, it shows you so much detail in the corona, solar atmosphere. You got the poles, and then you got all of these. It's quite intrinsic, and I'm going to show you what I'm going to be doing. It's going to be quite unique. So,
Tony,
yeah.
Good. Go back one slide. Also, features on the moon are slightly visible here also.
yeah, well, because it's a long exposure,
Right,
and
yeah.
it's stacked.
Yeah, I'm saying, yeah, this.
Yeah, it's a combination of long exposure and stacked.
Yeah,
You see detail on the moon.
this is a very.
This is not easy to do. It's not like your average person could do this. So the corona is, I'll tell you about this photograph so you can tell. Do you know why this is streaming up here? Because of the camera lens. Camera lens is causing a diffraction. It's not from the eclipse. But this is I want to show you because there's a lot of times when you do these pictures with your camera lens, depending upon what you have, you're going to have artifacts in the camera lens. So I'm just trying to show you what an artifact can be. So this is a diamond ring. Girls like this one, and the artifact from it. Okay. So what I've been doing a lot of research on, and I think I'm going to try to do something. It could be very unique that hasn't been done before. I don't know, but I'm going to go into detail what I've been doing. It's photographing the corona polarized light. Okay, the corona is polarized, and I'm going to go into what polarization means. And I'm going to go photograph it in K light. Polarization is in two states. It's P, or linear polarized, and S polarized. In layman's term is that if you bought those variable polarizing filters you have, and if I understand, some people may understand, when you turn it one way, you barely can see through it, and you turn the other way, you can see through it. When you can see through it, that's linearly polarized, that's P polarized. So I'm going to look at the corona only in that light, in the P polarized light. I'm photographing P polarized light. To do this, I designed a thin film polarizer. As shown, it was designed using my software, and then I programmed my IBS machine, ion beam sputter machine, to do it. Two very highly advanced things I'm doing right now. I'm not done. So I'm including in the talk, but I'm not finishing what I'm doing. So this is not easy to photograph in polarized light. I'm making a special aluminum mount. Now, here's the thing, and listen up. Yep. So the way I'm going to do it is, this is my camera lens that I have here. This is this lens here is a very large Canon lens that I purchased a number of years ago. This is an FD lens, okay, and this lens is about at least 3 or 4 inches in diameter. I don't know exact diameter. It has in it, I can't see over. So in this lens, it has your F ratios. Okay. Now, and I forgot to mention this before, when you're using your camera to photograph it, don't leave your F number open all the way. Stop it down and stop it too. It makes it a little more clear by doing that. So this one has from F4.5 all the way up to 32. So I'm going to put it at F5.6. Okay. And then I have an adapter that I purchased that goes from FD to the new Canon EOS adapter. Now, I designed a very extensive mount where one end is going to go onto this Canon and mount, and the other end is going to attach to my Canon FD, my Canon camera. So this adapter, this camera is going to go over here, and the adapter is going to be about 2 or 3 inches long. It's going to attach to it. Inside that adapter, the aluminum adapter that I'm making, is the polarizing filter is tilted at 45 degrees inside there. So this is a pretty elaborate mount. I don't have it. It's being manufactured right now. It takes a lot of time to do the manufacturing of the mount that's being done and to do it right. So once that's in place, that lens is going to see the polarizer here. Now, this is the thin film design that I designed, the polarizing. So basically, this is what the optics looks like. So what happens is the P polarization light is going to go straight through, and the S polarization is going to get reflected. So I'm only going to see a linear polarized light that's going to be coming out of here. This is the initial design that I'm using. So the blue is the P polarization and the red is the S. So I'm initially using this design. Now the wavelengths are 500 to around 550 because this is the part of your vision, the best part of your vision. So that's what I chose so far. I didn't finish this design yet, but I think pretty close. This is what it's going to be like. And so close to the sun, the K corona is strongly polarized, and the F corona is essentially unpolarized for eclipse studies. Polarimetric observations can be used to completely isolate the structure of the K corona, enabling high contrast, high resolution images of the inner and middle part of the corona. So I'm essentially going to try to photograph this solar eclipse in a way that I don't remember. I don't know of it being done before. So the different layers in a solar corona emits light through different processes, including emission, scattering, absorption. The K corona, E corona, and the F corona are named after the types of light emissions they exhibit. The K corona is produced by Thomson scattering of photons by free electrons in the corona and dominates distance greater than 2 million kilometers from the photosphere. I don't want to lose everybody too much, but there's a lot of theory behind what I'm doing. So the E corona is produced by specific electronic transition ions and blah, blah, blah. The F corona is a mirror-like reflection in the photosphere caused by cool gas containing elements of like hydrogen and carbon, is mainly detected through the infrared observations. All right, so what happens with the corona of the sun? The corona is the outermost layer of the sun's atmosphere, where strong magnetic fields bind plasma and prevent turbulent solar winds from escaping. Corona, the outermost region of the sun's atmosphere, consists of plasma, hot ionized gas. It has temperature of approximately 2 million degrees Kelvin and is extremely low density. The corona continuously varies in size and shape as it is affected by the sun's magnetic field. That's why you're seeing all different shapes that's happening with the corona. So this will always continuously change, and that's an artifact because of the longer exposure and reflection in the camera lens. And again, this here is multiple images to make that eclipse strip, and then the diamond ring effect. And over here is the partial, total, and then the partial again. So just to sum up what I'm doing with this thing, so I'm building a whole setup for doing this thing to photograph the eclipse in a different polarization of light, and it's called linearly polarized or P-polarized light. And I want to see what I'm going to get. I don't know. I'm hoping for the best, but I'm not going to rely on this. I'm going to rely on this taking all my pictures of the eclipse, which I know I'm going to get. So I'm banking that I'm going to get this thing because there's a lot of theory and a lot of research that I'm doing on that. I have to align this thing here over the before the eclipse. So which scene in here, scenes in here. Okay. I had to make this special adapter, which came out pretty good, that I can adjust it so it'll do that. But I haven't done this yet. So everything's a little premature. I'm in the middle of working on it. You have any questions at all on what I'm saying? And then you got the beautiful diamond ring effect. This color here, this magenta color is an artifact. I don't know when they printed it. I don't think it looks like that. So again, so here's the sun, there's the earth, and there it focuses on it where the eclipse is going to be, and usually totality is always in a weird part of the world that we can't go to or don't want to go to. All right, during the 1919 total solar eclipse, that's when my father was born in 1919, it proves his theory. Einstein's general theory of relativity suggests that the sun's gravity bends the light path from distant stars. It's a testable prediction, but only during a total solar eclipse. The eclipse of 1919 fit the bill precisely. So Einstein was involved during that 1990 eclipse, and there's pictures of him here, and you can see the apparent position of the star changing. And this is what he predicted. And during the 1990 eclipse, Einstein was at the totality looking at this.
He became a superstar overnight.
Yes. Yes, he did. Because, you know, you can have theory. I'm going to go further, but you can have a theory, but when you show that your theory is correct, that's when you become a superstar. So on May 19th, Einstein's 4-year-old theory of general relativity was put to the first test during a total solar eclipse by measuring the image of the star shifts when the sun is close by. And with a lot of care, you might be able to repeat this famous test from 100 years ago. So if you guys want to do it, I'll show you an idea. So give me a minute. A total solar eclipse occurred on May 19th with a duration of a maximum eclipse of 6 minutes and 50 seconds. That's really long. It was the longest eclipse since May of 1416. A longer total eclipse would later occur in 1937. What is significant about the 19 eclipse? It was a determination of light bending matched the general relativity prediction. It proved his theory of relativity. The 19 eclipse, okay. The 1919 eclipse tick mark shows where the light bent original image. It's hard to see, but it's right there. And it shows you how the light got bent. They put tick marks here to show where it is. And I got a bunch of pictures of the eclipse. This is a composite of the corona and the solar flares. You're not going to get eclipse. You're not going to get a picture like that. This one here is a photograph taken with a professional observatory with a grating, and they got both the corona and the flares, and it's all colors in it. It's a polarization. I mean, the different kind of grating they use to take that picture. And this is a flash spectrum of the sun. The professional observatories do this. And if you look carefully here, this tells you the wavelengths of light that they're at and what it is, the composition of the light of the material inside. So this is where we're going to see. We're going to start here, end up here, and go back to here. So that's what we're going to be able to see during this eclipse when we're able to go there. Now, for the good stuff. Some people are controversial about stuff, but I found a Chinese site where you get a lot of really cheap stuff, and it's not bad. What?
I wouldn't trust a solar filter.
Well, you may not. I tried it. It's fine. So maybe you don't use it. All right, don't use it. I have used it, and they work fine. So this is a Mylar filter, and it really looks almost identical to that other Mylar filter I have. This Mylar filter here that you see here, I bought it at the time before I knew that. I bought it right away because I figured it gonna be sold out. This was from Orion. This was $160 I paid. That $17.
Tony, what's the difference between the Mylar filter and plotter film?
Plotter doesn't make anything. They buy it. So it's just they bought a different type of plastic
Okay.
And they
The
call it
bother
bother.
is Mylar.
Yeah, they're all Mylar.
Yeah,
okay.
and the advantage of bother is it's high quality because it's bother planetarium, so they tested in the rest.
Yeah, but it's,
Well, we call it Mylar because it looks like Mylar, but
But it's not.
but it's not the same Mylar that helium balloons are made out of. It's a
Right.
different material.
Yeah, when Tony talked about a rescue blanket, I mean, you have no idea what that's coated with,
Right, right.
and you don't know if it's a common thickness of the Mylar. So the bother, I think I bought a square foot of bother, maybe, and it was $50.
the bottom line is that if it's Mylar filter, quote unquote, it's so thin, all right, it's not gonna make any difference on who you're gonna get. The only difference is the density's gotta be right, okay?
I'm guaranteeing that this filter is made by the same factory that makes the 6-inch. I have a 6-inch Celestron
Right.
filter. It's identical and they're all made in China.
That's the
Guaranteed
thing. This is,
selling the
he's exactly
thing
right.
without the Celestron markup.
When you have Bada, all the stuff Bada's products are made by other companies, not
I
Bada.
don't have.
Don't get me wrong, they have high quality Bada, but they're buying from everybody and they're buying things from China. Okay, so the only thing is that you have to test it out yourself, whatever you plan on buying, because make sure it's good enough for you, or read the reviews. Yeah. No,
Kids.
before I go in this site and I buy anything, this, see, it's literally says model for Celestron. Because that's where Celestron buys it from. I guarantee you. And I'll tell you another thing, I wouldn't buy that until I read the reviews. There are probably 300 people buying this filter, and you read every one of the reviews. What's the matter, John?
Reviews are meaningless.
Not necessarily.
Fraud companies can. fake
Well, I have not had
reviews.
a problem
Yeah.
going by reading
Yeah.
a whole bunch of them. Yes, there's gonna be people are gonna say things, but you're not gonna have 100 people say false statements. You're gonna have people that are gonna throw in there, say things, but there are gonna be some people that are gonna be using it and making good comments about it. So that's how I've done it. I haven't had a problem. I guess there are sometimes with what has been done, it's like a scam. What the company does is they have their friends post things, oh, this is really, really good, and it really isn't. But in this case, for this company, their reviews are substantial amount of people that are buying this stuff. And you go through the reviews, and that you should have a good idea, because besides the fact that you can have a perfect product, you're always gonna have somebody knocking it down. So no matter what. So you gotta read the reviews, and I've learned by going through a lot of the reviews, and it may like at a 5 rating, they're a 4.6 or 4.7. It can't be that bad. So I haven't had problem with this company. I've been buying stuff, and their quality has been decent. And then this is like some of the astronomical stuff that they sell. They sell these small refractors. They sell Plasso eyepieces. Their only eyepieces they sell are 1.25 inches, not 2 inches. They got fantastic reviews I've been reading on some of their eyepieces, and they physically look good. They physically look good, and they have a lot of pictures of them. So you can get like, I'm talking about like $10 for a Plasso eyepiece that their people are raving about, and they're aluminum mounts, there's no plastic in them. Then they have different telescopes, small telescopes, different things that you may want to go on the site. And look and see what they have. But the bottom line is words to the wisdom. You gotta research it and look into it and see if it's worth getting. I have not had a problem. Okay. Basically, I haven't tried. Does that mean everything they sell is good? No, not at all. Not at all. But there's a lot of stuff they do sell are dirt cheap. And stuff for components. Like they have a lot of eyepieces there, but they're all 1.25 inches. And they're all I think all of them are Plasso. They sell Barlows. They sell, it's nothing really high end either, but they do sell, and some, I don't know if that's it. I bought a night vision goggles there. And it's like a regular night vision. It works. Like it would cost me like under $100. And I can look in the sky and it's definitely really good. And it's not a green image, it's a white image too. So all right, I want to wish everybody best of luck dodging the clouds to see a special eclipse. And that's it.
Very good.